cooling curve.
Recording in progress.
Okay. In the cooling curve, just like we did for the heating curve, in heating curve we were started our discussion from the solid, like you have a solid and you melt it, and then you get a liquid, and then the gas is formed. In the cooling curve, as the name indicated from this, cooling curve means
Yeah.
that you are cooling the
Solid.
water. Okay, you are cooling the water.
Yeah.
So it means initially you have a gaseous form, right? And then from gas, you are converting
To
that
liquid
gas into liquid, yes, and then
to solid.
into solid, yes, exactly.
Mm.
So basically, what will happen, according to you, what can happen? Firstly, when we are discussing the three states, you must think about the atomic arrangement, how atoms are arranged in the gas, how they
Like
are
far,
arranged.
like
Atoms
faring
are,
apart.
yeah, they are far apart from each other. In the liquid,
Yeah.
they are also far apart, but not as much far apart, just like in gas, right?
Yeah.
And in solid, they are close to each other.
Very near.
Yes,
Yes.
they are very near to each other. Okay, so you have gases. In gases, intermolecular forces are less. There are weak
Yeah.
interactions, right? There are weak interactions in the gas.
Mhm.
So what will happen?
Yes.
What we discussed in the heating curve was that you were having a solid, right? And by increasing
Yeah.
temperature, what you were doing? You were
To
breaking the
break the
intermolecular
intermolecular
forces,
force.
right? You were breaking them.
Yeah.
Now what is
Yes.
needed in the opposite?
M-
You need to form,
Maybe
or you need to. Mhm. What can happen then? मेरा फोन देना, मैं ना नेट ऑन कर लूँ, नेट बंद हो गया। हाँ, लाइट क्यों हो गई, क्या हुआ? अच्छा, ये उसके साथ वैसे भी होता है। कैन यू हियर मी?
Recording in progress.
yes. Hello.
Okay. I was telling you, I was asking you what can happen in the cooling curve. The
Yeah, I was
intermolecular
going to say
forces will. Mhm.
maybe like give like how do I say, like maybe
There will be formation of
like give
intermolecular
less
forces,
heat.
right?
Yeah.
Intermolecular forces will form, right?
Yeah.
Because you need
Hmm.
interaction now. In if you
Yeah.
see in the gas there are weak interactions. Now you want to make liquid from the gas, right? You want to make liquid from the gas. So what do you need? You
Yeah.
need to increase intermolecular forces. You need to increase intermolecular
Molecular force.
forces or
But how do
interactions.
we increase it?
How we break them in the heating curve?
By
How?
heat,
Yes. So what will happen in the
giving a lot
opposite?
of heat.
When you are going opposite, so what can happen in the opposite?
Uh,
By
give more
decreasing the temperature.
cool.
By decreasing, yeah, by
Oh,
decreasing.
decrease.
Simply. The cooling means you
Mm.
are decreasing the temperature, you are lowering it. So
Mm.
in this, what we need to do? We will decrease the temperature. Clear? We will
Mm. Yes.
decrease the temperature. So this is the
Stem.
exact opposite of the heating curve. Okay. So you need to
Hmm.
decrease the temperature. That is what is known as cooling curve. That actually you are cooling the gas. When you are cooling the gas, what will happen? You are decreasing its temperature. Okay. When you are decreasing the
Yeah.
temperature, what will happen? The atoms will come closer to each other. And when they come closer to each other, their
Hmm.
interactions will increase. And then the gas will convert into liquid. Okay.
Oh, it's liquid.
This is how we get
Yes.
liquid oxygen or liquid nitrogen. Have you ever heard about this? That you
Yes.
have liquid nitrogen, you have liquid oxygen. Even though you know oxygen is a gas, how we get liquid
Yeah.
nitrogen? In this way, like you have a
Uh,
gas, you have nitrogen gas, you decrease its temperature, then it liquefies. Okay, then you get liquid nitrogen.
mhm.
Are you getting this concept?
Yes.
Okay, that is why we say that cooling curve is exact opposite and it is the mirror image of the heating curve. Okay, what happens in the heating curve? If you understand that, opposite, exactly opposite will happen in the cooling curve. Like you have in the heating curve, what we were doing, we were increasing the temperature, right? And then there was solid,
Yeah.
and from the solid, the liquid was formed, and from liquid, the gas was formed. In the cooling curve,
Hmm.
we will go in the opposite direction. You have a gas, you are decreasing its temperature. And why we are decreasing the temperature? To increase the intermolecular interactions, okay? To increase the intermolecular interactions. And why it is needed to increase the intermolecular interactions? So that we can get liquid. Clear?
Yeah.
And then by further
Yes.
decreasing the temperature, what will happen? If you have a liquid
We're
and
gonna get solid.
yeah, you will get the solid because when you decrease the temperature, the interactions will increase. Okay,
The
intermolecular
intermolecular
interaction.
forces will.
Yes,
Yes.
intermolecular interactions. You can say interactions or forces will increase. Actually, the forces are forces of interaction. So that's why I'm saying intermolecular forces of attraction will increase. So they will attract, and then from the liquid you will get a solid. Clear?
Yeah.
This is now we can start from here. The temperature remain constant at 100 degree and 0 degree. Okay, the same will happen over here. At the 100 degree, you see this line. This is this is constant at 100
Yeah.
degree. And for
Hmm.
0 degree, you have also constant line for a few minutes.
It's
Why is
constant.
this so?
Mhm.
Initially, we started from the 150, the higher temperature. So it means there was a gas at this temperature, right? And now you are cooling it. So when you cool it down, what will happen? The particles motion will decrease, right? Because in the
Yeah.
heating curve, we discussed that when we increase the temperature, what happens? The particles movement increases, right? You remember in the in the heating curve,
Yeah.
we discussed it. The kinetic energy increases. Remember that point? Over
Yes.
here, I told you that you increase the temperature, whenever you increase the temperature,
The kinetic energy will.
yes, kinetic energy increases. Okay. And when kinetic energy
Yes, will
increases,
increase.
what happens? The
The
movement
heat
increases,
increases.
right? The movement of
Uh,
particles
Particles increases.
increases. Okay. Now, what we are doing? We are doing opposite of this. We are decreasing the temperature. Okay. So when we are decreasing the temperature, what will happen? The kinetic energy of the particles will decrease. And when the kinetic energy will decrease, the movement of the particles will
The movement will decrease.
decrease. And when the movement will decrease, what will happen? The particles will come closer to
Um,
each other. Okay.
yes.
And then the liquid will
Yes.
form.
Hmm.
Particles will come closer to each other. Clear?
Yes.
So this is what happening over here. If you see the first point, let me highlight it. This is the first point. This one. They are saying as the gas cools, the particles move less quickly with less energy. They don't bounce so far apart when they collide. Now what they are saying that by cooling the gas, they don't bounce. Why they will not bounce? Because in the now what you have done, you
Less
are
kinetic.
yes, there is less quick movement. Okay, that's why they will not
Yeah.
frequently bounce. Just like in the heating curve. In the heating curve, there
Mhm.
was when you see the boiling water, what happens? The bubbles they pop up on the surface of the water. Have you seen the
Yeah.
boiling of the water?
Yes.
So
Yeah.
yeah. So what happens is that the particles they collide with each other because there is increased temperature,
Mhm.
there is kinetic energy of those particles was increased. That is why. In this case, now you are cooling the gas, there are less movements, and when there are less movements, there are less bouncing of the particles. The particles will
Yeah.
bounce very less, and then when you further decrease, when you have decrease the temperature to 100 degrees Celsius, what will happen? At this, you will get by 100 degrees Celsius, the particles in the gas do not have enough energy to bounce apart. Okay, what they are saying,
Hmm.
they don't have enough energy to bounce apart when they collide. Like what they are saying, Okay, there is something we need to discuss on one more. Okay, no fun. Okay, they are saying that when you have temperature increased, okay, what happens is that the particles they have haphazard motions. So they come closer to each other, they collide with each other, and then they bounce back. Okay, then they bounce back. When you have increased temperature,
Yeah.
okay, this happens at that. But when you decrease the temperature, when you decrease the temperature, what will happen? The the particles which come closer to each other, they will remain close to each other. They will not bounce back. They will not
Mm.
bounce back. This is what they are saying. Because they don't have enough energy to bounce back. In this state, when the temperature was increased, at that time they were having enough energy. Okay, they were having enough energy
Mhm.
at that time. So that is why they tend to bounce back. In the first case, when you were giving the temperature in the heating curve, but when you decrease the temperature, what will happen? When the particles will approach each other, when the particles will come closer to each other, they will not bounce apart. And why they will not bounce apart? Because they don't have enough energy. Because you have decreased the temperature, right? When the temperature is
Yes.
decreased, there is less energy. Are you getting this point?
Yeah.
That why particles will not bounce back in the cooling curve? Because they don't have enough energy. When they approach each
Mhm.
other, they will remain closer to each other. And why they will
Yeah.
remain closer to each other? Because in the cooling curve, their temperature is decreased, and due to this decreased temperature, they cannot bounce apart. They will remain closer to each other. Opposite happens
Mhm.
in the heating curve. In the heating curve, when you heat any substance, the particles approach each other because their kinetic energy was increased. Okay, and due to this increased kinetic energy, when they approach each other, they bounce with each other and they bounce back, they bounce apart. After bouncing, they go in
Mhm.
different directions in the heating curve. But in the cooling curve, opposite happens. What happens in the cooling curve?
That like it goes from like a gas form to liquid to solid.
Yes, from I am asking about the this bouncing concept. Are you clear with this?
Oh yeah. So it has less kinetic energy.
Yes, in cooling curve, the temperature is decreased, their kinetic energy is decreased, so they will not bounce back.
Yeah.
When they
Less
approach each other,
movement.
yes, when they approach each other, they will remain closer to each other. They will remain
Yeah. Uh,
closer
Closer but not
to
bound.
each other. Yes, they will not bounce back because they don't have enough energy to bounce back. They will remain in the same state. Okay,
Yeah.
this is what they have mentioned over here. That by 100 degrees Celsius. Okay, read this from the first point. Firstly, read the first
Okay.
one. As the
Okay.
gas cools,
As the gas cools, the particles move less quickly with the less energy. They don't bounce so apart when they
so
collide.
far apart.
By 100
Yes.
degrees so far apart when they collide. By
Hmm.
100 degrees Celsius, the particles in the gas do not have enough energy to bounce apart when they collide. The forces of attraction between them take over. The gas condenses to a liquid. This releases the heat, so even though you keep on cooling, the temperature does not fall again until all the gas has liquefied. By
Okay.
0 degrees
No,
Celsius,
stop.
particles in
Till
the liquid.
till
Yeah.
this. We have discussed till this. Now, what they are saying in the part two. Are you clear with the part one? What they have mentioned in the point one? That
Yeah.
initially the
Yes.
gas, when the gas cools down, what happens? The particles' movement decreases.
Will be less. Yeah.
Yes. Why the particles' motion will be less? Because they
Because
have,
less energy.
yes, because they have less kinetic energy.
Less energy.
And then they don't bounce back. They don't bounce
Yeah.
far apart. Okay, then what happens at 100 degree?
At 100 degrees, the particles in the gas like doesn't have enough kinetic energy to bounce apart,
Hmm.
like when they collide with each other,
Hmm.
and what's it called?
The forces of
The
attraction
gas
will increase
condenses.
in them.
Yeah, yes, and then the gas condenses to a liquid,
Okay, what is
which
meant
will
by
release all the
condensation?
heat.
Condensation means initially in the gas the particles were far apart from each other. Condensation means they
Yeah,
will come closer to each other. They will come closer to each
yes,
other. Okay, this is what we say the condensation process. Okay, so the gas condenses to liquid,
yeah.
and what happens then?
That will like release all of the heat energy.
Hmm. Because you are
Yeah, and
cooling it. Okay,
then
because
yes, and
but the
then
temperature does not fall. Okay, they can ask you
yeah.
why at 100 degrees Celsius you have the gas is converted into liquid, but the temperature is not changing at 100 degrees Celsius for few minutes. What will be your answer? How can you justify this statement that at 100 degrees Celsius the gas is converted into liquid, the gas is converting into liquid, but why temperature remain constant at 100 degrees Celsius for few minutes?
So until like the
Read this
gas
paragraph
has
again and then let me know about this.
okay, by 100 degrees Celsius, the particles in the gas do not have enough energy to bounce apart when they collide. When the forces of attraction between them take over the gas condenses to a liquid, this releases heat. So even though you keep on cooling, temperature does not fall again until all the gas has liquefied. So maybe it's constant. So until the gas has been turned into a liquid form.
Okay, yes. And we say that the temperature does not fall because at this stage the gas the heat is released at this point. After that, from point 2 to point 3, if you see this point, this one, this three, what is
So
happening? The
it
liquid,
loses like heat. It loses heat energy. Yeah.
yeah, in this because this is opposite.
Hmm.
You know, the cooling means heat energy is released. How cooling will happen?
Yes.
Let's just think about it. In the heating, how heating was happening? You were providing the temperature, you
Uh,
were providing the heat,
heat
right?
energy.
Yes. And when something
Yeah.
cools, like you have a cup of tea or a cup of coffee, what happens after some time, after 5 or 10 minutes? It cools down. Why?
It will
Because
cool.
the heat in that cup was released into the surrounding, right?
Mm-hmm.
Have you observed that?
Yes. Yes.
That
Yes.
how things cool down after a few minutes, how the cooked food cools down after a few minutes because all the heat which was being absorbed by the food will be released into the surrounding after sometimes. Okay,
Mm-hmm. Yes.
so this happens over here that the heat will release and the gas will cool down to the
Mm-hmm.
liquid. Okay, then when we move forward from this liquid state till this, you get what you get how a solid will form. Basically, you are decreasing temperature. You are decreasing the temperature of
Uh.
a liquid. What will
Yeah.
happen?
Mm-hmm. Like the intermolecular forces will come together,
Yeah,
so it
they
will
will
form
increase.
liquid into
In
solid.
in
Yeah.
liquid there were we said that in gases there are very less intermolecular forces, right?
Yes.
Because the gas
Yeah.
particles are far apart from each other. But in liquids, they come closer to each other.
Yes.
They come closer, and intermolecular forces increases, right? What
Yes.
happens when you further decrease the temperature of a liquid? The intermolecular forces will become more stronger.
Will
Okay?
come
Yes,
more. Yes.
they will increase, their strength will increase, and intermolecular forces will become more stronger, and then you will get the particles close to each other, just like this. Okay, the particles will be closer to each other, and you will get a solid. Clear?
Yeah. Yes.
So this is what they have mentioned. Now you can read this and tell me what is happening by 0 degree.
Okay, by 0 degrees, the particles in the liquids move so slowly that stronger forces of attraction take over and the lattice starts to form. The water freezes, solidifies to ice. This process also releases heat, so the temperature doesn't fall again until all the water has frozen.
Yes. So by 0 degree, what they are saying, the particles in the liquid, they will move so slowly. Now their movement will further decrease. Their motion will further decrease, right? The motion will further
Yeah.
decrease. What will happen when the motion will decrease? The particles will be closer to each other. They will have stronger forces
Yes.
of attraction. Okay, stronger intermolecular forces. You can say stronger intermolecular forces, or you can say stronger forces of attraction. Both are same things, but you have just two different terminologies for the same thing. You can say that their
Yes.
intermolecular forces will increase, or else you can say there will be stronger forces of attraction in them, in the liquid, when
Mhm.
you are further cooling it down. So at 0 degree, what is happening? Firstly,
So, like what's it called? The water loses heat energy to go to
hmm.
solid to
Now
like
what is
like
happening at 0 degree. I am asking this point. What is happening but with the liquid at 0 degrees Celsius?
the particles like move slowly, so that the
Hmm.
stronger intermolecular forces and the force of attraction take over and
Hmm.
starts to form a solid.
And yes, they have mentioned that they will start to form a lattice. Now, why they have mentioned lattice?
Yeah.
We have discussed about it. That in the solid,
Yes,
if
so,
you remember, yeah, in the properties of the solid, we have discussed it that in the solid you have lattice, right?
yes.
You have a regular arrangement of the particles in the solid. So this is what they are saying that in the liquid, the particles, if you see, when you decrease the temperature of the liquid, what is happening when you decrease? There is,
The forces of attraction will take over.
yes, the forces of attraction will increase and the
Take over.
motion will
Yes.
decrease, and the lattice will start to
Mhm.
form. Okay, why lattice is forming over here?
Mhm. Because like the stronger intermolecular forces
Yes, because you
is
see
coming
what they
together.
have mentioned. There are This is a liquid state, right? This is a liquid state. Now what they're saying that the
Yeah.
liquid movement will decrease and forces of attraction will be stronger. So it means the forces of attraction are
Mhm.
stronger means the particles will be closer to each other, right? The particles will be closer
Yes.
to each other. And when the particles are closer to each other, what will happen? There will be a lattice formation, right? That is why they have
Yeah.
mentioned it. Lattice. The lattice will start to
Mhm.
form. Whenever it you see this terminology, lattice start to form, it means the solid is forming. Because we have discussed this
Yes.
property in the solid. That solid have a proper lattice. Lattice means a
Mhm.
proper regular arrangement of the particles. Regular arrangement of particles, right? Clear? Are you getting this?
Yes. Yes.
Okay. Then afterwards, there is uh, the water freezes. Okay, they have mentioned now the water freezes. Lattice means the water will freeze. It solidifies to ice. This process also release it. Okay, they have mentioned now that this process will release it. Always remember this thing. Whenever you are decreasing the temperature of something, whenever there is decrease in the temperature of something, it means that thing is releasing heat. Okay, that thing is releasing heat.
Yes.
And if there
Yeah.
is a material and that material is after some time its temperature is increased, so definitely that body has absorbed the heat. Okay, I am saying if you have two bodies, let's say you have one body this initially its temperature was 100 degrees Celsius, right? And after some time, after some time its temperature will decrease to 20 degrees Celsius. Now can you tell me what is happening? The body A is releasing heat or it is absorbing heat?
Absorbing heat.
Is this absorbing heat?
No, 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 releasing,
Yeah,
release.
it is releasing heat. This is what I am saying.
Yes.
That whenever there is a decrease in temperature, it means there is definitely there will be a decrease in temperature. Okay, whenever there is a decrease in temperature, it means the body is releasing heat. Clear?
Hmm.
And if you have a body,
Yes.
right? You have a body, and initially its temperature was 0 degrees Celsius, and after some time, its temperature increased to 25 degrees Celsius. Now, what is happening? Is this body absorbing heat or releasing heat?
Absorbing heat.
Yes. So, this is what they have mentioned in both the curves. In one curve, in the heating curve, we discussed. Okay, now can you tell me what happens in the heating curve and what happens in the cooling curve in terms of the heat? In the cooling curve,
The cooling curves,
heat
the
releases
heat
or heat
is
absorbs?
released and
The body absorbs heat or body
it
releases heat?
releases.
Yeah, it releases heat. The
And
body will
in
release heat. Okay.
heating curve, it
Yes.
will be absorbing heat.
Yes. In the heating curve, the body will
Absorb
absorb heat,
heat.
and when it will absorb heat, what will happen? The in the heating
The
curve,
temperature will rise up,
yes, the temperature rises, and when the temperature rises, what
and
happens?
the kinetic energy will
Yeah, the
increase.
kinetic energy of the particles increases, and when the
Yeah.
kinetic energy increases, what happens?
The intermolecular forces will
Intermolecular
be more
forces.
stronger. We will also like
No,
increase
intermolecular forces will
the
decrease.
attraction. Yeah, decrease.
They will decrease
In
because you are
cooling curve,
increasing
it
temperature.
increases.
Okay,
Yes.
when you are increasing temperature, the intermolecular forces will be decreased. Why this will decrease? Because when you
So it
increase
can
the
break
temperature,
the.
yes, there is enough energy to break these forces. Okay, the kinetic energy, there is
Yes.
enough kinetic energy to break these forces. So that's why the intermolecular forces will decrease. Okay, and the
Yes.
movement will increase. The movement of particles
Mm.
will increase,
Increase.
and when the movement will increase, definitely you will get gaseous form. Okay, in the first, over here you were having solid, then the solid the temperature will increase, and then up to so on. Now can you tell me this for cooling curve, what happens in the cooling curve?
So cooling curves like releases heat,
Releases heat.
and the temp yeah, releases heat,
Okay, then,
and the temperature will decrease.
okay,
Less kinetic energy.
kinetic energy will also decrease
Yes, and
because there is
the
less temperature.
intermolecular forces will increase.
Yes, the intermolecular forces will
Increase
increase. Now why they will increase?
because the kinetic energy is less.
Because
It
now
decreases.
there is you cannot mention the kinetic
Less
energy is
kinetic.
decreased. You will say intermolecular forces will increase because when you decrease the temperature, what happens? The particle come closer to each other. Okay, the
Mhm.
particles
Yes,
come closer to each other, and when they come
each
closer to
other.
each other, they don't bounce back. Okay, they don't bounce back. So
Yeah,
this is the reason over here, that when you
the
decrease
movement
kinetic
will
energy,
decrease.
yes, when you decrease the kinetic energy, the
It
movement,
won't bounce back.
yes, movement decreases, particles don't bounce back. Okay, they remain closer to each other.